Have you ever truly stopped to consider the incredible, often invisible journey a product takes before it lands comfortably in your hands?
It's pretty amazing when you think about it.
Right. From the single coffee bean starting maybe thousands of miles away to the smartphone you might be holding right now.
Yeah.
There's this hidden world, a silent, complex ballet of parts and processes.
A global orchestration, really.
Exactly. And we rarely give it a second thought, yet it underpins almost everything about our modern lives, how we consume things. So today, we're taking a deep dive into that fascinating, often unseen world, supply chain management, SEM for short.
Yes. Let's unpack that.
Think of it as peeling back the layers, layer after layer, of how goods and services actually move. From the rawest materials all the way to your doorstep.
It's that intricate dance, ensuring everything's where it needs to be, when it needs to be there.
And ideally at a cost that makes sense. So our mission for you, our listener, is to really extract the essential nuggets of knowledge from the sources we have.
We've got some great material to work with.
We really do. We'll look at the core building blocks of SCM, dive into how performance is measured, meticulously measured, actually uncover the decision-making models guiding strategy.
And even the physical layout of the facilities, how the buildings themselves work.
Exactly. We'll focus on key definitions, critical processes, the fundamental tools you absolutely need to grasp this field.
So by the end, you should have a solid framework.
Yeah, a clear framework packed with hopefully some surprising facts and practical insights. You'll get the why and how of modern commerce a bit better. Okay, let's unpack this. You've given us a fantastic set of sources, so much to explore here.
Well, what's truly fascinating, I think, is how these elements that seem quite separate, strategy, performance metrics, even warehouse layouts, they actually form this tightly integrated system, a living system almost.
That's a good way to put it.
If you connect it to the bigger picture, it's fundamentally about optimizing value and efficiency at every single stage.
Right.
It's not just moving boxes.
No, it's strategic movement, smart movement.
Exactly. That creates competitive advantage and ultimately makes customers happy.
The foundation is a supply chain management, the core building blocks and network players.
Okay, so where do we even start with something this massive? A global supply chain. It's huge, but our source material gives us a great starting point. The core building blocks.
Right, the fundamentals. These aren't just abstract ideas. They're the concrete functions every effective supply chain has to manage, day in, day out.
So mastering these individual bits and how they interact, that's the key.
That's absolutely the key. It allows the whole system to work smoothly, adapt when things go wrong, and deliver value consistently.
Okay. Our sources list 6 critical areas, 6 core building blocks. Let's break them down one by one. Each seems crucial.
They are. And understanding each one helps build the overall picture. So the 6 are demand management, procurement, inventory management, operations, logistics, and distribution.
Got it. 6 key areas.
Grasping what each does and how they depend on each other. That's vital.
So first up.
First up, demand management. This is really about understanding customer needs, predicting them, even influencing them sometimes.
Okay, so this is where it all begins. Predicting what people will buy.
It really is. Because if you don't have a good handle on what customers want, when they want it, how much, well, the whole chain can either seize up because you don't have enough stock.
Or get clogged with stuff nobody wants. Expensive stuff just sitting there.
Precisely. So think forecasting trends, digging into sales data, even looking at bigger things like economic shifts or, cultural trends that change what people buy.
It sounds like a mix of science and art.
It really is, even with all the data. Forecasting.
Right.
It's tricky. A misstep, say, predicting demand for a hot Christmas toy. That can mean millions, even billions, in lost revenue or wasted product.
Wow. Okay, high stakes right from the start. So once you've got a handle on demand, how do you get the actual raw materials, the components?
That takes us straight to the second block. Procurement. This is all about acquiring the necessary goods, services, or maybe specialized work from an external source.
So buying stuff, basically, but strategically.
Exactly. Sourcing raw materials like oil or cotton, getting specific electronic components, even buying the packaging. It's getting the right inputs, right quality, right time.
And the right price, I assume.
And the right price, absolutely. But the challenge today isn't just cost. It's about building strong, reliable relationships with suppliers.
Ah, the relationship part.
Yeah, ensuring ethical sourcing, navigating geopolitical risks, things that can suddenly cut off your supply of something vital. People think procurement is just haggling, but it's sophisticated relationship management.
Strategy.
Okay, so Demand managed, materials procured. What about managing all the stuff you now have?
That's inventory management, our third block. The continuous tracking and control of everything a company holds, raw materials, stuff being worked on, finished goods.
The delicate balance you mentioned earlier.
Exactly. A constant tightrope walk. Too much inventory. You've got capital tied up, storage costs, insurance, risk of obsolescence.
Right. Stuff goes out of date or fashion, but too little. Missed sales, production delays, unhappy customers, big problems. So it's a constant optimization game, often using complex algorithms, maybe just-in-time systems.
JIT, yeah. To keep holding costs down but keep things available.
Precisely. Minimize costs, maximize availability. That's the goal.
Okay, so demand, procurement, inventory, balanced. Now, the actual making of the thing.
That brings us to operations. Block number 4. This covers all the processes involved in transforming those raw materials into finished products or, delivering services.
This is the doing part.
It's the doing part. Manufacturing, assembly, delivering the service itself.
Right.
Inside the factory or the service center, it's about efficiency, quality control, maximizing output.
So for a tech company, it's building the circuit board.
Yeah. Or for a coffee shop, it's the whole process of making and serving your latte. Operations is where value is physically created, but it's also where inefficiencies can pile up fast if you're not careful.
Makes sense. Okay, what's next? Block 5.
Block 5 is logistics. This is the detailed coordination of the whole complex operation, moving things efficiently, point A to point B.
So transport, but more than just transport.
Much more. It's the planning, implementing, controlling. The efficient, effective flow and storage of goods, services, information, from the origin point right to the consumption point.
Wow. Okay, so coordinating trucks, ships, planes, trains.
All of that. Plus the paperwork, customs, everything involved in moving things smoothly. And optimizing logistics isn't always just about speed.
Oh, what else?
It's often balancing speed with cost, with environmental impact, with reliability. That's where you see complex route optimization software, even AI, trying to find the absolute best way.
Fascinating. Okay, one block left, number 6.
And finally, number 6, distribution. This is the process of moving the finished good from where they were made to the point of sale, getting the product into the customer's hands.
The final leg of the journey.
Exactly. Often involves regional distribution centers, last mile delivery services, retail channels. Logistics handles the broader movement. Distribution is specifically focused on that final delivery.
And that last mile can be tricky, right?
Incredibly tricky,
Let's
especially
look.
now. Urban congestion, customers wanting things faster and faster, the push for sustainable delivery options, it poses huge challenges and drives a lot of innovation too.
That's a fantastic breakdown. Let's try to visualize it. Imagine a major car manufacturer launching a new EV, right?
Good example.
Every single one of those blocks is critical. A slip up anywhere. Disaster. So predicting sales for the new EV, that's demand management.
Right. How many will people buy next year?
Then sourcing the specialized batteries, the chips, the rare earths from suppliers all over the world. That's procurement.
Getting all those vital components.
Managing the thousands of parts waiting for assembly, maybe using that JIT approach, that's inventory management.
Keeping just enough, but not too much.
The actual building of the cars on those robotic assembly lines, that's operations.
The transformation process.
Moving engines from one plant to the final assembly, or shipping finished cars across continents, that's logistics.
The complex movement piece.
And finally, getting that shiny new EV to the dealership, or maybe even delivered right to your house, that's distribution.
Final handover.
And like you said, a snag anywhere, a delay in procurement, a bottleneck in operations, a problem in distribution, it ripples through the whole system. Costs go up, delays happen, customers get annoyed.
It's all deeply interconnected.
And it's not just one company doing all this in a vacuum, is it? The supply chain. It's more like an ecosystem, a whole network of players.
Absolutely. The sources are very clear on this. The supply chain not only includes manufacturers, suppliers, and distributors, but also transporters, warehouses, and crucially, customers themselves.
Right, defining it broadly is key.
It is. For a complete picture, lots of different entities contribute.
So let's quickly tick off who these main players are. Manufacturers, they're the ones actually making the product, right? Turning raw materials into finished goods.
Correct. Often the core of the production process.
Then suppliers, they provide the bits and pieces, the raw materials, the services to the manufacturers.
Exactly. They're upstream. Their reliability is absolutely vital.
Distributors, they help sell the product, like middlemen between manufacturers and retailers, or maybe direct to customers.
Yes, They manage the flow of goods out to the market points.
Transporters, the movers, trucks, ships, planes, moving goods between all these points.
The physical arteries, you could say, often managing complex routes, different modes of transport.
Warehouses, more than just storage sheds, right? Vital hubs.
Oh, absolutely vital. For inventory management, holding stock near customers, sorting, packing, getting goods ready for shipment, critical nodes in the network.
And finally, customers. You said they're often overlooked in the operational view.
They are, surprisingly often, but they are absolutely integral. They drive the demand in the first place. They provide feedback. The entire process is ultimately geared towards them.
So why is it so important to formally include customers in the definition?
Because it forces you to remember the ultimate purpose. It's all for their needs, their satisfaction. From that first demand forecast to the final delivery, and even after sales support, their feedback reviews, returns, calls is gold for continuous improvement.
That makes total sense. To make it even more real, our sources give some specific company examples, big ones involved in SEM.
Yes, they mentioned two consumer goods giants specifically, HUL, which stands for Hindustan Unilever,
Okay, HUL, Hindustan Unilever.
and P&G, which is of course Procter & Gamble.
P&G, Procter & Gamble. Right, these are important acronyms to know, especially for potential MCQs.
Definitely. HUL Hindustan Unilever, massive multinational, foods, beverages, home care, personal care, huge reach, especially in Asia and Africa. Managing their supply chain means dealing with incredible diversity, geographies, consumer tastes, distribution challenges.
And Procter & Gamble, P&G, similar scale. Another global giant.
Exactly. Huge portfolio of brands. Tide, Pampers, Gillette, you name it.
So the key point about mentioning HUL and P&G is their scale.
It's the sheer scale and complexity. Their supply chains are unbelievably intricate, spanning continents, thousands of suppliers, millions, maybe billions of customers, delivering tiny sachets to remote villages in some cases.
Wow. They need incredibly sophisticated systems then.
They absolutely do. Highly sophisticated systems to manage all those building blocks, all those network players simultaneously efficiently. Their entire business depends on it. It's their competitive edge.
Okay. Beyond these basic blocks and players, the sources also mention broader strategic things, considerations for SEM.
Exactly. These are the higher level issues that companies like HUL and P&G and really any serious business need to think about constantly.
What are they?
Well, first, the source mentions the framework of core building blocks for SCM, which basically reinforces what we just discussed. These blocks aren't silos. They have to be integrated strategically, aligned with the overall business goals.
Seeing the whole system, not just the parts.
Precisely. Second, enhancing supply chain resilience. This is huge right now. How do companies make their supply chains tough enough to handle disruptions?
Like pandemics, natural disasters, trade wars.
All of those. Geopolitical events, cyber attacks, sudden demand shifts. Resilience isn't just about avoiding single points of failure, like relying on just one supplier. It's about building agility, adaptability.
So maybe not always chasing the absolute lowest cost.
That's offer the trade-off. Maybe dual sourcing adds a bit to the unit cost, but it makes you more resilient. Or maybe nearshoring, bringing production closer, costs more initially, but cuts lead times and global risks. It's about long-term stability, not just short-term cost.
That is a critical point. What else strategically?
Third, strategic approaches to SCM. What's the overall game plan? Are you going for lean operations, minimizing waste, agile supply chains reacting super fast to market changes? Or maybe focusing on sustainability meeting environmental and social goals. Each strategy demands different choices all along the chain.
So defining your overarching approach.
Yes. And fourth, implementing supply chain management in your business. This is the practical side. Taking all these ideas, strategies, principles, and actually making them happen. Change management, adopting new tech, redesigning processes, the how-to.
Okay, so we've laid the foundations, the blocks, the players, the strategic thinking, but how do companies know if they're actually doing a good job? How do they measure success or spot problems?
The critical question. And that leads us perfectly into performance measurement. Our sources point to a really powerful tool for this, benchmarking.
Mastering performance measurement, the power of benchmarking and gap analysis.
Right, benchmarking. This is where it gets really interesting, isn't it? Because you can't just guess if you're doing well. You need to measure, compare.
Exactly. And knowledge is power, but only when you apply it. Benchmarking gives you the insights you need to understand where you are, set targets, and improve, based on what actually works, based on best practices.
So, for listeners who might have heard the term, what exactly is benchmarking in the SCM world? Our source
Yeah.
defines it pretty clearly.
It does. Benchmarking in supply chain management,
Yeah.
it involves comparing your organization's processes, performance metrics, and practices with those of others. The others could be competitors, leaders in other industries, or even different units within your own company.
So, looking outside your own bubble.
Essentially, yes, to identify areas for improvement and learn from those best practices. The source also says a benchmark is basically a standard of performance.
A target to aim for.
A standard, yeah. Benchmarking helps you find those standards elsewhere and then successfully import them, adapt them to your own situation. It's not just copying, it's understanding why something works and making it work for you.
Okay, that makes sense.
Yeah.
But why bother? It sounds like a lot of effort. What's the real payoff for a company?
Oh, the payoff is huge.
Well-
The purpose is clear. It helps companies understand their strengths and weaknesses, pinpoint exactly where they need to improve, and ultimately significantly boost their supply chain performance.
So, tangible benefits.
Absolutely. Two big ones are highlighted. First, it helps organizations make better informed decisions. Decisions based on data, on how others are performing, are always stronger than decisions based on gut feeling.
Evidence over intuition.
Right. Second, and this is really powerful, it exposes organizations to innovations and breakthroughs. You might be stuck in your ways, not even realizing what's possible. Benchmarking opens your eyes to new tech, new processes, new ways of doing things that others are already succeeding with.
It stops you getting complacent.
Exactly. It challenges the status quo by showing what's achievable.
Like your car fuel efficiency example earlier. If my car gets 30 mpg, but a similar competitor gets 40 mpg.
Benchmarking helps you figure out how. Is it their engine design? That's a practice. Or maybe their manufacturing tolerances give better aerodynamics? That's a performance metric. It gives you a target and clues on how to hit it.
Got it. Now, our sources break down benchmarking into specific types, different ways to compare.
Yes, and this is important for knowing what lens you're using for comparison. 4 main types are highlighted.
Okay, what's the first one?
First is performance benchmarking. This is about gathering and comparing quantitative data, numbers, measures, key performance indicators, or KPIs.
Like delivery times, costs, inventory levels.
Exactly. On-time delivery percentage, inventory turnover rate, transport cost per unit. It's usually the first step. It tells you what the performance gaps are numerically.
Okay, performance is the what? What's next?
Second is practice benchmarking. This looks at the qualitative side. How an activity is actually done, the people, processes, technology. It's about the how behind the numbers.
So not just the delivery time, but how they achieve that fast delivery.
Precisely. How does that leading company manage its warehouse team? What specific steps are in their order process? What software are they using? This gets at the methods that drive the results.
Makes sense. What's the third type?
Third is internal benchmarking. This is where you compare metrics or practices from different parts of your own organization.
Looking inside.
Yes, different units, product lines, departments, maybe different countries. Like a multinational comparing its European distribution center's efficiency against its Asian one. It helps spread best practices internally.
Okay, and the last one, number 4.
Finally, external benchmarking. This is comparing your metrics or practices to one or more other organizations outside your own walls. This is often what people first think of.
Like comparing your clothing store's online delivery to Amazon's.
Exactly. Even if Amazon's in a different sector, they might be best in class for logistics. You learn from the absolute leaders, wherever they are. This often yields the most eye-opening insights.
Okay, 4 types. Performance, practice, internal, external. So once you've done your benchmarking, you have all this comparison data. How do you make sense of it? The sources mention gap analysis.
Right, gap analysis is the crucial next step. It's the process companies use to compare their current performance with their desired expected performance.
So comparing where you are now to where you want to be.
Exactly, or where the benchmark shows you could be. The analysis determines if you're meeting expectations using resources effectively. It highlights the gap.
The difference between reality and the goal.
Precisely. Benchmarking finds the external best practices or sets the targets. Gap analysis identifies the specific internal shortcomings you need to fix to close that gap. It makes the need for improvement concrete.
So if a company decides, okay, we need to do this benchmarking thing properly, Our sources lay out a kind of roadmap, steps to follow.
Yes, a step-by-step guide to make sure it's not just an academic exercise, but leads to real change. It's a structured process.
What's step one?
First action listed is understanding the government process to improve. Now, this doesn't mean national government. It means understanding your own internal governance, policies, maybe regulations you have to follow before you try to change things based on benchmarks.
So knowing your own internal rules and landscape first.
Right. Ignoring that can kill the initiative. Second, research to plan the review. You need thorough preparation. Define exactly what you're benchmarking, why, what resources you need, set clear goals for the project itself.
Okay, plan carefully.
And third, select appropriate organizations. Choosing who to compare yourself against is critical. Similar companies, industry leaders, someone brilliant at one specific thing you need to fix. The relevance of the comparison matters hugely.
Choose your benchmarks wisely. Step 4.
Collect data from selected organizations. This needs a solid method. Surveys, site visits, analyzing public data often needs cooperation, which takes networking. The quality of your data is everything here.
Garbage in, garbage out.
Exactly. Fifth, identify barriers to change. Okay, you've found a best practice or a gap. Now what's stopping you from adopting it? Cultural resistance, old technology, lack of budget. You have to figure out the internal roadblocks.
Address the obstacles proactively. And the final step.
Finally, make recommendations for change constructive and convincing. Don't just point out problems. Propose actionable solutions. Explain why they'll work. Build a strong business case to get people on board and actually drive the change.
So it's a whole process from planning to implementation. Benchmarking tells you where to aim, gap analysis shows you where you're falling short, and this process helps you get there.
That's a good summary.
But before acting, even with all this data, you often need to make big strategic choices about the supply chain itself, its design, its direction. Which brings us to the models that guide those decisions.
Strategic decision-making in the supply chain. Normative and descriptive models.
Right, and this section really underlines the analytical side of modern SCM. These models aren't just theory, they are practical frameworks for tackling complex problems, making big strategic bets, navigating uncertainty, often involving huge investments.
They're essential tools for strategy or design, the source says.
Absolutely. They provide a structured way to approach decisions that would otherwise just be overwhelmingly complex. Too many variables. They help businesses make informed choices to optimize things and stay competitive.
Okay, the sources talk about two main types of models here. The first is normative models. What are they? What kind of questions do they answer?
Normative models tackle a very direct question. What is our best course of action in a given situation? They're prescriptive. They aim to give you the optimal solution, the single best decision, based on your inputs, your constraints, your objectives.
They tell you what you should do.
Exactly. The examples given make it clear. They're used to determine the best location for a new store or figure out the best level of advertising for a product. In both cases, the model crunches the numbers to point to the ideal answer to hit a specific goal, like maximizing profit or minimizing cost.
Finding the optimal path.
That's the idea.
So, back to that e-commerce company expanding. A normative model could take their customer data, competitor locations, shipping costs, labor costs, and tell them, okay, based on all this, this specific town is the mathematically best place for your next warehouse.
Precisely. It prescribes the optimal solution to that defined problem.
Okay. And then there are descriptive models. How are they different? What do they do?
Descriptive models are different. They answer questions like, what will happen if we do X? They don't necessarily tell you the best thing to do. Instead, they describe the likely consequences, the outcomes, the impacts if you were to take a certain action or if a certain scenario unfolds.
So they predict the future based on choices, what-if scenarios.
Exactly. The examples show this well. They're used for exploring a set of alternate assumptions or scenarios, like what happens to our profits if raw material costs jump 10%? Or what if a big competitor enters our main market?
Understanding potential futures.
Yes. They're also used for finding explanations for things by identifying causal links. Like, why did that new product sell poorly? A descriptive model might help pinpoint if it was weak distribution, bad marketing, or something else. And critically, they're used for predicting possible outcomes based on changes. What market share might we get if we add this feature?
So if that apparel company is thinking about switching its shipping partner doing X,
a descriptive model could project the impact. How might delivery times change? What would happen to costs? How might customer satisfaction scores react based on the new partner's track record? It helps them see the potential ripple effects before they commit.
Understand the repercussions, manage the risk.
Precisely. Crucial for complex supply chains where one change can affect so many other things.
Okay, so normative models prescribe the best way. Descriptive models predict the what-ifs, both vital for strategic decisions. But eventually, those decisions have to translate into physical reality, which leads us to facility layout, the actual spaces where things happen.
Designing efficiency. Supply chain facility layout.
Yes, and this raises a really important, often underrated question. How does the physical arrangement of a space, a factory, a warehouse, directly impact the efficiency, the safety, the cost-effectiveness of the entire supply chain?
It seems obvious it matters, but maybe the scale of the impact is overlooked.
Hugely overlooked sometimes, but it's incredibly impactful. It influences throughput, worker morale, costs, delivery speed, everything. A bad layout can literally cost millions.
Okay, first things first. Definitions. Our sources distinguish between supply chain layout and facility layout. What's the difference? They sound similar.
They're related but operate at very different scales. Both are critical, though.
So what's supply chain layout, the big picture?
Exactly. The source calls it a visual representation or model of how a business chain functions, from raw materials all the way to the end customer. Its purpose, to help spot inefficiencies across the entire network, factories, warehouses, transport routes, and optimize the whole system for cost reduction and better efficiency. It's the macro view, the map of the whole network.
Okay, the network view. And facility layout, that's the micro view, inside one building.
Precisely. Facility layout is the arrangement of the workspace within a single building or operational area, a factory floor, a distribution center, an office. The source gives that great hospital example. Pediatrics needs to be near X-ray.
Right, shows how adjacency and flow inside are critical.
Absolutely. A well-designed facility layout can slash movement time for people and materials, boost safety, improve productivity within that building, even make it a better place to work. It's about smart use of every single square meter.
Okay. The sources also bring up two key concepts influencing facility design and operation, especially in manufacturing.
Yes, fundamental concepts for optimizing flow, aiming for speed and consistency.
What's the first one?
First is the continuous flow model. This is described as a supply chain strategy designed to ensure a constant, uninterrupted movement of products through the supply chain.
Like that river analogy they used. Smooth, no interruptions.
Exactly. Minimize stops, delays, inventory piling up anywhere. Aim for a seamless flow. Very much linked to lean manufacturing ideas.
Okay, continuous flow. And the second concept.
Second is assembly lines. An assembly line is specifically designed to arrange various components into a final product that conforms to standards set in product design.
The classic manufacturing setup.
Right. And its purpose is explicitly stated to divide complex tasks into small, easy-to-learn segments that can be repeated over and over. This division of labor, the sequence, it dramatically boosts efficiency, speed, consistency for mass production.
So both are about optimizing movement and process. Continuous flow is the bigger strategy. Assembly line is a specific way to implement it.
That's a great way to put it. Both drive efficiency and cut costs in the system.
So when companies are designing these layouts, what are they actually trying to achieve? What are the main objectives?
The objectives are pretty comprehensive. It's not just about speed. Our sources list several key goals. First, to provide optimum space to organize equipment and facilitate movement of goods and create a safe and comfortable work environment. So efficiency and human factors, making sure machines fit, flow works, and people are safe and reasonably comfortable.
Okay, efficiency and well-being.
What else? Second, to promote order in production towards a single objective, ensuring everything is logically sequenced, aligned, contributing to the main goal without confusion or backtracking.
Makes sense. Streamlined purpose.
And third, really crucial today, to facilitate extension or change in the layout to accommodate new product lines or technology upgradation. Build in flexibility, future-proof the design. A rigid layout can become obsolete fast.
Right, adaptability is key. So those are the objectives. What criteria do they use to make the actual layout decisions to meet those objectives?
The criteria are critical, balancing various factors. The source lists the main ones as workflow efficiency, space utilization, accessibility, flexibility, safety, and the nature of the product or service. Those are the core considerations.
And the source goes into more detail on those.
It does, it elaborates. The design should optimize space utilization and use every bit effectively. Minimize material handling, less movement means less cost, time, damage. Reduce bottlenecks, clear those points where things slow down. Improve workflow, make it smooth, logical, predictable. Reduce costs, labor, energy, everything. Safety and flexibility, absolutely paramount. Ultimately, improve customer satisfaction through faster, reliable service. And finally, minimize waste time, motion, resources while enhancing productivity. Create an environment for effective work.
That's a lot to balance. So those are the goals and criteria. What actually influences the final design? What factors shape the choices?
Good question. The influencing factors vary, but some common themes emerge.
Such as?
First, the design of the facility layout should consider overall objectives set by the organization. The layout has to physically support the business strategy, cost, leadership, innovation, speed, whatever it is.
The physical space reflects the strategy.
Exactly. Second, optimum space needs to be allocated for process and technology. Different processes, different machines need different kinds of space. A chemical plant needs a different layout than a software development office.
Obvious, but crucial.
Third, a proper safety measure as to avoid mishaps. This is non-negotiable. The layout must promote safety, meet regulations, protect workers.
Safety first.
Always. And fourth, the overall management policies and future direction of the organization. A company planning rapid growth needs a more scalable, flexible layout than one focused on a stable market. Long-term vision shapes the physical design.
Right. And when they're actually designing, are there specific considerations they always try to keep front and center? It's like design principles.
Yes, 3 critical design considerations that really guide the practical side.
What are they?
First is flexibility. The design must provide for expansion or modification. Things change. New products, more demand, new tech. An adaptable layout saves massive disruption and cost later. Think modular.
Be ready for change. Second,
Space utilization. An efficient layout reduces time in material and people movement and promotes safety. Using space well cuts wasted motion, saves cost, reduces worker fatigue, improves safety by reducing congestion.
use space wisely. And third
Is capital. The design should be minimal in terms of capital investment. Yes, it's a strategic investment, but you aim for cost effectiveness. Get the best outcome without overspending unnecessarily.
balance function with finance.
Oh.
Okay. So how do they do it? How do they create these layouts? The sources list 3 techniques.
Right. Practical tools to plan and visualize.
That's the first technique.
2 or 3-dimensional templates. These are essentially scaled down models, little miniatures of machines, desks, walls that you can move around on a floor plan.
Like playing with dollhouse furniture, but for a factory.
Kinda. It gives a very tangible feel for spatial relationships, helps visualize different arrangements, great for collaboration.
Okay, physical models.
Yep.
Second technique.
Sequence analysis. This utilizes computer technology to design the layout. It analyzes the sequence of operations or material flow, which department talks to which other department most often, and then arranges them, maybe in a straight line or a U shape, to minimize travel distance or time.
Using data to decide placement.
Exactly. Data-driven layout optimization.
And the third technique.
Line balancing. This one is used specifically for assembly lines. It's about distributing the tasks evenly among all the workstations on the line.
Why is that important?
To maximize output, minimize idle time, you don't want one worker waiting while another is overloaded, and ensure smooth, continuous production flow. Critical for assembly line efficiency.
Got it. Now, the sources also categorize layouts into 6 main types. A classification system.
Yes, understanding these helps choose the best fit for a specific situation. Each has pros and cons.
Let's take one.
Line layout. Think classic assembly lines. Products move sequentially through fixed workstations. Good for high-volume, standardized products, like cars.
Okay, line layout, type 2.
Functional layout, also called process layout. This groups similar functions or equipment together. All the drills in one area, all the welding in another.
So products moves between functional areas.
Yes, depending on what processing they need. More flexible for varied products, but can mean more movement.
Third type.
Fixed position layout. Here, the product stays put because it's too big or complex to move easily. Workers, tools, materials come to the product.
Like building a ship or an airplane.
Exactly. Or a large custom machine.
Fourth type.
Cellular technology layout. This groups different types of machines into work cells. Each cell handles a specific family of parts or products that have similar processing needs. It's a kind of hybrid approach.
Try to get the best of both line and functional.
In a way, yes. Improves efficiency for specific part families.
Fifth type.
Combined layout. Pretty straightforward, it's a hybrid, mixing elements from 2 or more other types to fit specific needs. Very common in practice.
Tailoring the layout. And the 6th one, it sounds like a technique, not a type.
Yes, the source lists computerized relative allocation of facility technique, CRFT here. And you're right, it later clarifies it's really a computer-based technique for optimizing layouts, not a layout type itself.
Ah, okay. So CraftT is a tool for designing layouts.
A very powerful one. It optimizes the relative placement of departments based on material flow data, aiming to minimize total handling costs. So important, it sometimes gets lumped in with the types.
That makes sense.
Okay.
And it leads nicely into the role of computers. No surprise, they're huge in optimizing these complex layouts today.
Oh, absolutely indispensable.
Yep.
Manual methods just can't handle the complexity or speed needed now. The sources highlight several computer-based procedures.
Including CRAFT, which we just mentioned. What does CRAFT stand for again? That seems like a potential MCQ question.
It does. CRAFT stands for Computerized Relative Allocation of Facilities Techniques.
Got it. Computerized relative allocation of facilities techniques.
Yeah.
And who developed it? Also sounds like MCQ fodder.
Developed by Buffa and Armour, pioneers in the field. CRAFT is foundational for minimizing material handling costs through iterative computer analysis.
Okay, Buffa and Armour developed CRAFT. Are there other computer tools mentioned?
Yes. The sources also list COCAD, which is Computer Facility Design, and ILDP, standing for Automated Layout Design Programs.
COCAD and LOD. More acronyms.
More acronyms. These tools, along with CRAFT, let designers rapidly test thousands of layout options, analyze complex flows, and optimize with incredible precision. The result: better, safer, cheaper facilities and more competitive supply chains.
Makes perfect sense. Now, beyond just layout, the sources mention matrix codes. What are these, and why are they so important in SEM?
Matrix codes. A small detail with massive implications. Especially data matrix codes. These are those two-dimensional barcodes, like little checkerboards, that can store a lot more information than the old stripy barcodes.
Okay, like QR codes, but maybe more industrial.
Similar idea, often more compact and robust, designed for industrial tracking. Their role: the source says they enhance traceability, improve data collection, and streamline processes. That's the core function. Crucial for MCQs. What is the role of data matrix codes? Enhance traceability, improve data collection, streamline processes.
So what kind of information can they hold?
A huge amount in a tiny space. Part numbers, serial numbers, batch numbers, manufacturing dates, even tracking individual components within a larger product.
Wow. So connecting this to the bigger picture, what does that enable?
It enables incredibly granular end-to-end traceability. You can track not just a box, but maybe every critical component inside that box right back to its origin.
That sounds revolutionary for recalls, for example.
Absolutely critical. If there's a fault, you can pinpoint the exact batch, maybe even specific units, instantly. Saves lives, saves fortunes. It's also huge for quality control, anti-counterfeiting, and even consumer transparency. Sometimes you can scan a code and see the whole product story.
That level of detail, it really makes that invisible river of the supply chain visible, doesn't it? Tracking not just the product type, but the unique history of that specific item.
It fundamentally changes how companies manage risk, ensure quality, and build trust. A cornerstone of modern logistics. Outro.
Wow. Okay. That was a seriously comprehensive deep dive. From demand management and giants like HUL and P&G, right down to benchmarking types, decision models, facility layouts, and even those tiny but mighty data matrix codes.
It really covers a lot of ground, doesn't it?
It really does. It's amazing how many interconnected layers there are.
And what's fascinating, I think, is seeing how understanding each individual piece, the building blocks, the benchmarking metrics, the models, the layouts, allows organizations to build these incredibly resilient and efficient systems.
It's all about the interconnectedness, like you said earlier.
Exactly. How each part works together synergistically to create value for the customer.
Yeah, we've definitely seen how defining clear goals, measuring performance diligently against benchmarks, using those models to make smart choices, and then meticulously designing the physical spaces.
Yeah.
It's all part of this complex global puzzle.
And connecting it back, it really shows that every single detail matters. Where you put a department in a factory, what kind of barcode you use, it all impacts cost, efficiency, and ultimately customer satisfaction.
It makes the abstract idea of a supply chain very tangible, very real.
It does. It's the system that quietly enables so much of our modern lives.
So, a final thought for our listeners.
Maybe the next time you get a package delivered, or even just sip your morning coffee, pause for a second. Think about that invisible river. the processes, the decisions, the physical layouts that made that journey happen.
Consider the complexity behind the convenience.
Right. And maybe wonder what other hidden systems are out there, working with incredible precision, just waiting to be revealed. What else might surprise us with its complexity?
Keep exploring, keep questioning. Thanks for joining us on this deep dive.